On September 26, 1940, Mikhail Koshkin died from illness complications just as his T-34 design entered production at factories that would build 84,000 tanks using chrome-lined barrels capable of firing 5,000 rounds without cleaning. German intelligence reports from December 1941 documented Soviet medium tanks, whose sloped armor defeated 75mm guns at combat range, while rolling off assembly lines in tractor factories at rates that German precision manufacturing could never match. The mathematical brutality facing the Wehrmacht was absolute. An enemy that prioritized adequate performance through mass production over technical perfection, creating the industrial warfare equation that would determine the Eastern Front's outcome. The primary Soviet light tank in 1941, the T-26, faced a fundamental ballistic inadequacy against evolving German armor doctrine. Its 45mm gun could penetrate only 43mm of rolled homogeneous armor at 100 meters, sufficient against early Panzer II variants with 14mm frontal plates, but ineffective against the upper-moored Panzer III AUSFF entering service in March 1941 with 30mm frontal protection at 25-degree slopes. At the Battle of Brody between June 23 and July 3, the 8th Mechanized Corps lost 801 of 906 tanks to German forces, including the 11th Panzer Division with 150 tanks. The mathematical brutality was absolute. T-26 tanks destroyed by Panzer IIs and IIIs, mounting 37mm guns that penetrated Soviet armor at close range, while remaining immune to return fire. The mechanical problem compounded the ballistic inadequacy. Soviet BT-7 fast tanks weighed 13.8 tons, but carried only 13 to 20mm of armor, making them vulnerable to German 20mm autocannons at combat range. Their gasoline engines required constant maintenance in sub-zero conditions, with fuel consumption reaching 150 liters per 100 kilometers during winter operations. By October, during the Battle of Vyazma, Soviet forces lost 673,000 men and massive tank formations in 2 weeks. The few KV-1 heavy tanks proved too complex for field conditions, suffering high breakdown rates within operational distances due to 12-cylinder engines requiring skilled mechanics unavailable in forward areas. If you're interested in how wars are actually decided by logistics, math, weapons, and doctrine, subscribe now and turn on notifications. Let's continue. Mikhail Ilyich Koshkin received the design brief at Kharkov Locomotive Factory in 1937, weeks after Soviet intelligence confirmed German Panzer III production reaching 50 units monthly. The 41-year-old chief designer faced specifications that seemed contradictory. Create a universal tank weighing no more than 26 tons for rail transport, mounting armor effective against 75mm guns, capable of production in 10,000 unit runs by 1941. Koshkin reached for the Christie suspension system already proven in BT series tanks, the mechanism that would define his solution before he calculated a single armor angle. Its independent wheel arms allowed 53 km/h road speed while maintaining reliability across 500-kilometer ranges. The V2 diesel engine, a 500-horsepower 12-cylinder design displacing 38.8 liters, offered 300-kilometer range without refueling, critical for deep battle doctrine requiring sustained advances. The armor scheme represented pure mathematical optimization. 45mm steel plates sloped at 60 degrees from vertical created effective thickness of 90mm against incoming projectiles, matching the protection of much heavier designs through geometry rather than mass. Alexander Alexandrovich Morozov, deputy designer at age 37, refined the concept after Koshkin's death, from complications related to Illness on September 26, 1940. The December 19, 1939 approval came with brutal constraints. First production units ready by late 1940. Manufacturing distributed across multiple facilities to prevent single-point failure during wartime. The Christie suspension eliminated the complex interleaved road wheels that characterized German designs, reducing maintenance time from 24 man-hours for track changes to 4 man-hours using standard tools. Morozov's team chose diesel over gasoline for the V234 engine, reasoning that diesel's higher flash point reduced fire risk when penetrated by armor-piercing rounds. The transmission mounted in the rear compartment, separating it from crew areas and allowing engine replacement in field conditions by semi-skilled mechanics working in -40-degree temperatures. The T-34 contained 7,000 individual parts compared to the Panther's 15,000, a reduction achieved through welded construction rather than precision machining. The main gun, a 76.2 mm Zayas-5 F-34 with 30.5 caliber barrel length, fired 6.3 kilogram armor-piercing high-explosive rounds at 662 meters per second muzzle velocity. Its chrome-lined bore allowed 5,000 rounds without cleaning, a capability that matched or exceeded German gun durability, despite superior metallurgy in weapons like the 88 mm KWK-36. The armor-piercing round designated BR-350B penetrated 71 millimeters of vertical steel at 100 meters, 60 millimeters at 300 meters, and 41 millimeters at 1,000 meters when striking perpendicular to the target surface. Against sloped armor, penetration values decreased according to the cosine of the impact angle, but the tungsten carbide core maintained effectiveness against Panzer IV frontal armor at combat ranges under 400 meters. The sub-caliber round BR-240 achieved 110 millimeters penetration at 100 meters through kinetic energy transfer, though ammunition shortages limited its use until 1943. Production began at Kharkov Locomotive Factory in late 1940, transforming agricultural equipment lines into tank assembly within 6 months. The facility manufactured limited units in 1940. Then Stalingrad Tractor Factory surged to 316 tanks in 1941, despite constant equipment shortages and worker inexperience. The simplified manufacturing process eliminated complex curves in favor of flat plates joined at sharp angles, reducing welding time from 40 hours per hull to 24 hours by using less skilled labor. The Stalingrad factory embodied Soviet industrial philosophy, adequate performance through mass production rather than perfection through precision. Workers, many of them women and teenagers, assembled tanks using agricultural machinery adapted for military production. Steel shortages forced the substitution of all-metal tracks for rubber-tired versions, while paint shortages resulted in unpainted hulls rolling directly from assembly lines into combat formations. The chrome-lined gun barrels, produced using techniques developed for tractor engine cylinders, proved more durable than German equivalents, despite simpler manufacturing processes. By September 1942, the Stalingrad Tractor Factory had produced approximately 1,000 T-34 tanks, while under direct artillery bombardment from German forces advancing through the city. Daily production reached 10 to 12 tanks during the height of the siege, with completed vehicles often crewed by factory workers who drove them directly into combat against 24th Panzer Division elements approaching the facility perimeter. On October 16, 1942, 25 unfinished T-34 tanks emerged from the Stalingrad factory workshops, crewed entirely by plant workers under Factory Defense Command. The hastily assembled force engaged 24th Panzer Division units at ranges under 300 meters, destroying German Panzer IIIs and IVs while losing tanks to return fire and mechanical failures. Factory Director Ivan Mikhail reported preparing 50 additional tanks from assembly shops, armed with 1,500 DT machine guns and crewed by workers who had never operated military vehicles before the German advance reached the factory gates. The engagement demonstrated tactical principles that would define T-34 employment throughout the war. Soviet crews exploited their diesel engines' resistance to fire, advancing through burning buildings where gasoline-powered German tanks couldn't follow. The sloped armor proved effective against 75mm short-barreled guns at frontal aspects, forcing German gunners to maneuver for flank shots that exposed them to supporting infantry armed with anti-tank rifles and Molotov cocktails. Soviet forces recorded T-34 tanks firing continuously without barrel cleaning during the October fighting, penetrating Panzer IV side armor at 400 meters using standard BR-350 ammunition. The chrome-lined barrels maintained accuracy despite continuous firing, a capability that allowed sustained engagement without the barrel changes required by German tanks after prolonged combat. The tactical employment evolved rapidly as Soviet commanders learned to mass T-34 formations for breakthrough operations. Tank brigades received 65 tanks each by 1943, including 21 T-34s supported by lighter T-70 and T-60 tanks for reconnaissance and exploitation. The deep battle doctrine emphasized sustained advances of 50 to 70 kilometers daily, matching the pace that German armored formations had achieved during Barbarossa, but in reverse. Germany first recognized the T-34 threat in December 1941 intelligence reports from armored divisions. Assessment stated that T-34 sloped armor challenged German guns at combat ranges, while Soviet production rates overwhelmed German replacement capacity. By March 1942, OKW reports documented over 1,000 T-34s concentrated around Moscow, prompting immediate development of Tiger I and Panther tank programs designed specifically to counter Soviet armor advantages. The German response required massive resource diversions that fundamentally altered their war economy. Panther development consumed enormous steel allocations monthly, equivalent to the material needed for 200 T-34s at Soviet production standards. Each Panther required 60,000 man-hours to complete versus 25,000 for a T-34, a 3-to-1 labor disadvantage that Germany's shrinking workforce couldn't sustain. The Panther's complexity created vulnerability that Soviet simplicity avoided. Interleaved road wheel suspension required specialized jacks and 24 man-hours for track maintenance, impossible under combat conditions. Final drive failures affected 50% of Panthers within 100 kilometers at Kursk in July 1943, stranding advanced units without Soviet contact. German reports from April 1943 noted that T-34s built in tractor factories demonstrated superior reliability, while German Panthers suffered transmission failures before reaching combat. The economic arithmetic favored Soviet mass production over German technical sophistication. A single T-34 cost 270,000 rubles in 1941 compared to 900,000 rubles for a KV-1 heavy tank, allowing the production of 3 medium tanks for each heavy tank sacrificed. Total T-34 production reached 84,070 units across all factories between 1940 and 1945, with Stalingrad Tractor Factory alone producing 15,000 tanks, despite operating under siege conditions for 6 months. Peak production at Stalingrad reached 50 tanks monthly during early 1942, maintained even as German artillery targeted the facility directly. The simplified manufacturing process used 15,000 workers, many lacking industrial experience, but capable of assembling vehicles using agricultural techniques adapted for military production. Material requirements totaled 300 tons of steel per tank, less than half the steel needed for a Panther, while providing equivalent combat effectiveness against most German armor. The production surge continued even after factory evacuation. Equipment moved from Kharkov to Nizhny Tagil increased daily output to 20 tanks by late 1941, while dispersed manufacturing across 12 facilities prevented single-point failures that could cripple German production, concentrated in fewer, more vulnerable plants. Soviet labor productivity improved throughout the war as workers gained experience, reducing per-unit man-hours from 30,000 in 1941 to 25,000 by 1943. Lieutenant Dmitry Lavrinenko of 1st Guards Tank Brigade demonstrated T-34 capabilities during 1941 near Moscow, achieving exceptional confirmed kills including multiple Panzer IIIs, Panzer IVs, and anti-tank guns during several engagements. His tank fired hundreds of rounds without cleaning, maintaining accuracy sufficient for penetrating shots at 400 meters against German frontal armor. The engagement occurred at temperatures below -30 degrees Celsius, conditions that immobilized many German vehicles while the T-34's diesel engine continued operating. The Battle of Kursk between July 5th and 16th, 1943, saw 1,900 Soviet tanks, including many T-34s, engage 2,700 German tanks and assault guns in the largest armored clash in history. Soviet losses totaled 800 tanks at Prokhorovka, but field repair teams restored many to combat status within 72 hours using standardized parts and simple tools. German losses of 300 tanks proved irreplaceable due to complex manufacturing requirements and component shortages affecting Panther production lines. By 1944, T-34 limitations became apparent against Tiger. Two tanks mounting 88mm KWK-43 guns that penetrated 150 millimeters of armor at 2,000 meters. Soviet crews adapted by restricting engagements to 500-meter flank shots, using superior numbers and mechanical reliability to overwhelm German quality advantages through sustained attrition that German industry couldn't match. The T-34 concept influenced global tank development through derivative designs that prioritized reliability over sophistication. The T-54 and T-55 series, produced in 100,000 units based on T-34 principles, equipped armies worldwide from 1947 through the 1990s. Korean War fighting between 1950 and 1953 featured 300 Chinese-supplied T-34s against US M4A3E8 Shermans, with Soviet-trained crews achieving favorable exchange ratios through superior armor protection and gun penetration. Israeli modifications created the Shot Kal during the 1960s, upgrading T-54 derivatives with NATO standard ammunition and fire control systems. The basic T-34 hull design influenced Warsaw Pact armor through the Cold War, with sloped armor concepts becoming standard for all subsequent Soviet tank development. Even modern Russian T-90 tanks trace design lineage to Koshkin's original 45-degree armor slopes and diesel power plant configuration. Ukraine's 2022 conflict saw limited reactivated T-34 tanks deployed near Kharkov in March, 82 years after the original design entered production. The vehicles, pulled from monument displays and museum collections, provided mobile fire support against Russian forces using T-72 derivatives that themselves evolved from T-34 principles. Several tanks were lost to drone strikes, but the remainder continued operating despite ammunition manufactured in 1943 and minimal maintenance since 1945. The enduring legacy lies not in technical sophistication, but in relentless adequacy. 7,000 parts versus 15,000. 25,000 man-hours versus 60,000. 5,000 rounds without cleaning versus barrel changes every 2,000 rounds. The weapon succeeded through systematic simplification that enabled mass production under siege conditions, creating overwhelming numerical superiority that technical excellence couldn't overcome. The T-34 demonstrated that adequate performance multiplied by sufficient quantity defeats superior performance constrained by limited production. German engineering produced individual vehicles that outperformed any Soviet tank in direct comparison, but couldn't produce enough to matter when facing 15,000 tanks from a single factory. The mathematical reality of industrial warfare favored the side that built enough rather than the side that built best. If you enjoyed this deep dive into how industrial capacity shapes military outcomes, hit subscribe for more World War II engineering analysis every week. Thanks for watching.